Welcome everyone. In the previous lesson we saw the ref trait. The ref stands for the reference, and in this lesson we will talk about the drop trait. So drop lets you customize what happens when a value is about to go out of scope. We already talked about going out of scope and memory and things that get dropped automatically by the system. But now I want to go a bit more into the details on how we can provide our own implementation of the drop trait. This is why this is more advanced stuff. Okay, so if you have any problems on issues with memory, you can just leave a comment below, or you can reference to the old videos. So. The drop trait, you can provide an implementation for this drop trait. I remind you that trait is interface, so maybe you are more familiar with that term. So you can provide an implementation for the drop trait on any type, and the code can be used to release the resources when the values of your type they go out of scope. This can be used when we read and write on files, we do network connections, we work with sockets, locks, and so on. Why are we talking about the drop trait in the smart pointers section? Because I said that the drop trait. Why are we introducing the drop trait in the smart pointer section? Because I said that the drop trait is for any type, because it's most commonly used for smart pointers. So it makes sense to introduce it in the smart pointers section. So we will do a simple example when we will define a custom smart pointer like we did in the previous lesson. Then we'll implement the drop trait for this smart pointer, and then we'll create an instance of the smart pointer in the main function. Okay, in a nutshell, the drop trait is something that lets you customize what happens when this value goes out of scope. We'll see this now with this lesson. So we need to define the smart pointer. I think there is a typo here. So we need to define this smart pointer. To do this, I think we can use a struct. We did multiple lessons on structs. In this case, we have a struct called the custom smart pointer that has some data of type string. That's it. Then we need to implement the drop trait for this smart pointer. Okay, so here GitHub Copilot is smart. So here we don't want to do anything advanced, but we want to do something specific. To implement the drop trait, we need to provide the implementation for a single function called drop, using as a parameter here a mutable reference to self, to the instance itself. In this case, I want to do something very simple. I want when we go out of scope and this function will be called by the system, we will see this soon, to leave a log, to leave a print statement. Okay, so when we will do cargo run, we'll hopefully see this dropping custom smart pointer with data in the output here. So this is my implementation is just that I want to add a log. Okay. Now in the main function, I want to create two custom smart pointers. So we can do let underscore c equal custom smart pointer. We can use this one, my stuff. And then we can have let d. Okay, I put an underscore here because we will see, because we don't want to have a warning, okay, because we will use this just to basically, we'll create them and then we will destroy them. And then here we can print. Okay, so we create two of these functions, okay, with this string and this. Okay, now I have a question for you. What do you think will be the order of the output of this piece of code? So this is basically a function that is called when this instance go. This is the print statement that is printed when one of these two instances goes out of scope. So what do you think it might be the order? So we will have 3 logs, okay? We should have this one in the main statement, and then we should have this one printed for these 2, okay? Let's see. First D, then C, but I think it could go out of scope in any order. No, there is a specific order, okay? Let's try it out. Let's see if Sudansu is correct. Clear. Let's try it out. Let's try it out. Cargo run. Okay, so we have custom smart pointer created. Then we have other stuff, so D first, and then C. So when the drop function is called at the end of the scope, is always in a reversed order. So you'll have, in this case, first this one, this instance on line 35, and then the one on line 31. Okay? You were correct, Sudansu. Okay. Okay, so this is a basic example of using this custom storm trait. Yeah, because basically to clear the memory, it goes first like on what is at the end, and then it goes up until, because it's basically a stack. Okay, when you create these instances, it creates a stack, and so it starts popping from the top. That's let's say the in a nutshell. First in, last out. Yes, yeah, it's because it's using a stack. So yes. Filo. Filo is the Italian for thread. You know that. Okay. Okay. Perfect. Okay, so this was a first example. Now I want to remove this instance. I want to remove this underscore because I didn't want to see any warning. And now I want to talk about something else. What if I want to drop a value earlier? So this function drop is called automatically at the end of this function when it go out of scope. What if we want to force call it? Okay, this might be useful, for example, if you have some locks and we need to free the memory because we are using a smart pointer that needs at some specific moment to release the memory instead of waiting for the end of the scope. So the question is, can we do something like this? Can we just call this function like cdrop, something like that, and then we can print it? So this function drop, can we call it as as developers here in the main function using it? Cargo run. We have an error, okay? Let's read. Explicit use of destructor method. Explicit destructor calls not allowed. So this is here the compiler is very clear. Also, there is a spoiler of what I'm just about to show you, because the compiler is very precise and on point. So it's actually suggesting me what to do. So we will do exactly this. So instead of using the drop function here, we need to use something else. We need to type drop, which is basically standard memory drop. And then it's a bit different syntax. We need to use the instance that we want to free the memory. Okay. And now if we type cargo run, it works as intended. Okay, so let's read it. We have this custom smart pointer created, then we have this function called here. Basically, when we call this drop function for, this is std mem drop. We are calling this, which is not this function. This is another function in the standard library. And then we have the last print. Okay, so I want to stop for 1 minute just to think about why. Why do we need a separate function and we can't just use this function drop? Do you have an idea why we need a different one that does something similar, but we can't use exactly this one? What do you think is the reason why we need a separate function to do exactly the same? Because it's basically this is calling this function. So why? I think this Francesco, this is starting to like how I'm working with my vanilla JavaScript. I can't believe it. Why do we need a separate function? Why we can't just force it, cdrop? It seems like an overhead. Why do we need another function that does the same exact thing but with a different syntax, say calling this standard memory drop function? I will leave some time so you can give an answer. Because, you know, in Rust, they hate doing something that wastes the memory and stuff. So it seems a bit overhead. Why can't I just? Because it's outside the function. No, the drop. No, this function drop is in a trait of this instance. So why do we need to call something different when we can't just force it at some point? So we agree that this function drop frees the memory, okay, and frees all these instances. So why can't we do this during the scope? What's the problem? Why do we need another dedicated function that is in the standard library memory with a different syntax that uses this instance as an argument instead? The Rust developers just made a mistake. Let's see if we have one answer. Is it clear? If you want, I can repeat, Bob or anyone else. So we have this. Okay, fn drop is more like on drop than fn drop is more like on drop than actually dropping. More or less, Andrew. I think you are right, but I'm not sure that you're giving the correct answer here. Yeah, it's similar. So the idea is similar to on drop, basically. So what's the issue? Why I can't call it like during the instance? What's the issue? I think our answer is correct, but I want to be sure, Andrew. Drop C tells Rust to free memory, then calls our drop. I think this is also correct, but why? Why can't we just call the drop? This is correct, I think, Andrew. The drop C tells Rust it frees memory and then probably calls the drop under the hood, but let's say, but it handles. Okay, say I will drop it. You can't drop it. Like, give it to me. I will do what I have to do, and then I will drop it for you. Yeah, this is more or less what is what the std mem drop function works. But why? Why do we need this? Why do we need this? Let's see. I will give 10 more seconds. It's catching, interrupting and wrapping the output to null. Catching, interrupting and wrapping. Yeah, but this could be done by the function drop itself. This is exactly what the function drop is sort of doing. My question was, why do we need a separate function to do that? That was my question. Anyway, we need a separate function here, and we need to use the std mem drop because the drop function would be called anyway at the end of the scope. So if we had the same function called here, we would have the function called again at the end of the scope. So this is the answer. So we need in some ways handle this double call. We can't have a double call. So probably when we use this drop function for in the standard memory drop, this will handle that this will not be called again at the end of the scope because it has already been called first by the developer here. So this is the reason, because this is something that it will be called at the end of the scope. So this is the answer to this one. Yeah. Okay. So So to make a quick recap, so we just checked the drop trait. The drop trait lets you customize what happens when a value is about to go out of scope. So it's not just for smart pointers, but we introduced it especially for smart pointers because it's a clear use case for smart pointers as they have to do with memory handling and so on. And we saw a simple example, and we also saw how to drop a value early using the std mem drop function. Okay, in the next lesson we will see one more smart pointer called the reference counter, the smart pointer. If you have any question, you can drop them below. We are getting close to 50 episodes in this series, so I'm super excited, and see you in the next video. Bye bye.